Welcome and thank you for joining. In this lesson, we'll look into properties of various geometric shapes. Now, as you know, geometric shapes are full of patterns and connections, and some of them we have learned in the early grades. But this year, in grade 10, we are proving some of these connections, or as we call them, theorems, using what we call analytic geometry. Analytic geometry is the geometry that we can draw, or shapes we can draw, on the Cartesian plane. So in order to solve or to prove this theorem, you have to keep in mind these three main formulas. So this is the equation of a line in slope by intercept form. The slope is y2 minus y1 over x2 minus x1, where x1, y1, and x2, y2 are the coordinates of any point on the line. The midpoint formula tells us the coordinates of the point in the middle of a line segment. So for example, if you have a line segment with coordinates x1, y1, and x2, y2, then the coordinates of the point in the middle will be the average of x for the x coordinate and the average of y for the y coordinate. And lastly, the length of a line segment formula, which is basically the Pythagorean theorem, so the sum of the squares of the differences in x and differences in y values, but it is square rooted, so it has this big square root because we're trying to isolate L, so we don't have L squared anymore. So let's get started with our first example. So we're going to read the problem first. The vertices of a triangle are negative 3, 6, that's point A, 1, negative 6 for point B, and 5, 2 for point C. If M is the midpoint of AB and N is the midpoint of AC, verify that MN is parallel to BC. So as you notice, when you read a word problem in geometry, you can't visualize a solution without drawing a diagram first. So diagram step number 1. So we're going to read again and try to draw the diagram in the meanwhile. So point A has coordinates negative 3 and 6. That means that x is negative 3. Here is x equal to negative 3. X is negative 3. And y is positive 6. So y is positive 6, which makes this point location be here. So we're going to mark that point as A and write the coordinates as well. It's always good to have the information on the diagram because then we can see the connections a lot better. So next we have the point B. Now point B has coordinates 1 and negative 6. So that means x1, y negative 6. Here is x equal to 1. Here is y equal to negative 6. Here is the point B. Write the coordinates as well. Lastly, we have the point C. Point C has coordinates again, 5 and 2. Same way, x5, y2. So this is x5, this is y equal to 2. That's where the point should be located. Oopsie. And here is C, 5 and 2. All right, so next step, we have to connect all these points because we want to form the triangle. So let's form the triangle now by connecting A to B, B to C, and then A to C. Here goes our triangle. It looks a little bit like a right triangle, but never make assumptions in geometry. Always have to prove. So M is the midpoint of AB. Okay, I get this. So I have to look at side AB and try to visualize or try to estimate where the midpoint would be. It looks like this could be a good midpoint, but I can't really make that decision super quickly. I'm just going to draw the diagram for now. I still have to prove it with calculations, which we will do soon. And N is the midpoint of AC. So here is AC, and I would say that the halfway AC, we are at this point in here. And we're going to call it N. Now we're going to connect these 2 points because we want to talk about this line a little bit, the line MN. And next, we have to read the question. So we need to verify that MN, this is M to N, is parallel to BC. This is B to C. So what I'm trying to prove is that this is parallel to this. So let's get to work. First, I'm going to write what I have to prove. So I have to prove that MN is parallel to BC. Now, what does that mean? It means that the slope of line segment MN must be equal to the slope of line segment BC. So now I'm thinking, yes, I understand this, but how do I find the slope of BC and the slope of MN? Well, the slope of BC, we know that, just like any slope, delta y over delta x, or we're going to write the formula, yc minus yb over xc minus xb. Now remember that it doesn't really matter which point you use first. So you can write it the way we did, or you can put b first and c second. But what matters though is that if you start with b for the y coordinates, you got to do b for the x as well. Now we'll do the same thing for slope of mn. So we have y at m, or let's do n minus m over x at n minus x at m. So once we have set out the formulas in here, now we have to think, well, do we have the numbers to put in? So if you look at the slope of BC, we have the coordinates of both B and C. And we can easily substitute the coordinates to find the value of the slope. So let's do this first. So the slope of BC would be equal to y at c, which is 2, minus y at b, which is negative 6. So 2 minus negative 6. For the x coordinate, we have, again, from c, we are subtracting b. So 5 minus 1. So we got this. Simplify some more, and then you have 2 plus 6 over 5 minus 1, which is 4. And that would be equal to 8 over 4, or positive 2. So we got the slope of BC equal to positive 2. I like to box my answers so that I can see them more easily when I look for them, trying to check how far in the solution I am, okay? Or trying to connect whatever I get later with whatever I have. Now we're going to look into the slope of MN. Now, from M to N, we don't see coordinates. We're not given the coordinates. Instead of giving coordinates, the problem gave us the property of M and N, or the meaning, so what they mean to this diagram. So they are midpoints, right? So one is midpoint for one line segment, one for the other. So we're going to use their property to figure out the coordinates, what we want, right? And we're going to say that since M is a midpoint of A to B, we're going to use the coordinates of A and B. So we're going to start off here by finding the coordinates of M and N. Oopsie. So here we go. I'm going to say that the coordinates of M would be equal to xm, ym. And we're going to take the A and B values, negative 3 plus 1 divided by 2. That's x. And for y, we're going to say 6 plus negative 6 divided by 2. You write this better? Now we'll determine the coordinates of M. Negative 3 plus 1, negative 2, divided by 2, negative 1. 6 plus negative 6, 0, divided by 2, 0. So we're going to say that the point M will have the coordinates negative 1, 0. Don't forget the brackets. Next, we'll do the same thing for the coordinates of point N. So for point N, we're going to say xn, yn. Since it is a midpoint of A to C, we're using the coordinates of A and C. So for x, we have negative 3 plus 5 negative 3 plus 5 over 2, so the average of x. And for the y coordinate, the average of y is 6 plus 2 over 2. So that will give us the coordinates of n as negative 3 plus 5 is equal to positive 2 divided by 2, that's 1. And 6 plus 2, 8 divided by 2, 4. So now that we have the coordinates of both m and n, we will substitute them into the slope formula. So we have y at n, so minus y at m. So 4 minus 0. And x at n minus x at m. 1 minus negative 1. Now 4 minus 0 would be equal to 4. 1 minus negative 1, remember 2 negatives will make a positive, 2. So the value of the slope will be equal to 2. So we're going to say that the slope of mn is confirmed to be equal to 2. So now let's compare our boxed answers. So the slopes of mn and bc. So they're both equal to 2. So we're going to say that, in conclusion, the slope of mn is equal to the slope of bc. Therefore, the line segment mn is parallel to the line segment BC. And we're done. Now